Okay, team, this is our final algebra lesson, and it's word problem. So being able to look at a mathematical problem that's written out about a situation and turn it into an algebraic equation is the lesson and the skill that I'm trying to show you here. So I'm starting you off. I've just got some different words here. And basically each one of these correspond with a certain mathematical symbol or operation. So just beside each one, see if you can come up with which mathematical symbol that I'm thinking of. So you can pause, see how many you can get, and then unpause, and I'll go through them. Okay, so sum. The sum of numbers, we're talking about addition there. Sum is the answer to an addition question. Similarly, difference is the answer to a subtraction question. While I'm on that train, the product of numbers is the answer to a multiplication question. So uh, those are the mathematical operations that I think of there. If people are splitting something evenly, I'm usually thinking about, dividing that up between those people. If something's being quadrupled, then you got to multiply it by 4. Is has to do with the most important mathematical symbol there is. If something is something else, it means that we're probably going for it's equal to something else. The last one there that I haven't filled in is exceeds by. This one's always a bit weird, but if something exceeds something by a certain amount, like if my age exceeds yours by, I'm going to say 14, I'm like 19 years older than you, something like that. I don't know. If my age exceeds yours by 19, well, I would add 19 to your age to get my age, something like that. So there you go. So I'd be thinking of adding something, and then based on that, with these sentences here, can you turn them into a mathematical equation or expression? So again, I want you to try these on your own, and then I'll fill in one way to do them, but there's lots of ways to do it. So this first one, 5 more than double a number. How would I piece that together? Well, double some number would be 2 times that number. So whenever you're doing multiplication by a variable, you always want to put that number in front of the variable. That's how we're used to seeing it. If you have to combine like terms later, you're not going to make a mistake if you put it there. So that's double a number. 5 more than that would be plus 5. So you could write that one that way. And again, you don't have to use n. You can use any variable there. And you could have put the 5 plus first. You could do 5 plus 2n. It would be all the same thing. The sum of two numbers is 20. So what I would want to see for this one is something like x plus y equals 20. That's probably the best way to show that one, to show all the possibilities. If you had something like x plus x equals 20, that also shows two numbers adding up to 20. The big difference is, in this case, those two numbers have to be the same number. So we'd be talking about the number 10 there. Whereas this case, it could be 10 and 10. X and Y can both be 10, but it could be 11 and 9. It could be 22 and -2. It could be any of the combinations that add to 20. And that's kind of what that question is capturing here. The sum of two numbers is 20. It doesn't say that the two numbers are the same, so I'd want two different letters there. 10 times a number decreased by 7. So again, 10 times a number, put 10 times the variable, put the 10 in front of that. Decrease that by 7, we're going to subtract 7 off of that, like that. Oh man, going on, oh, this is embarrassing, like 4 years in a row I've had the same typo in this note, and I always forget to go fix it. And you know what? I'm going to keep it going. I'm not going to fix it this time. Triple the sum of a number and 3. So triple the sum of a number and 3. Well, the sum of a number and 3 might look like that, x plus 3. There's the sum of a number and 3. And I want to triple that, triple the sum of a number plus 3. Well, I'd have to put that in brackets and put a 3 in front of it. That's how I would multiply that by 3. Oh yeah, now we're getting into the main part of the problem, or the main skill that we're trying to go for here, which is taking stuff like that and turning it into, taking word situations, turning it into an equation so that we can solve. So here's our first example. I've got a few different examples here. The length of a rectangle is 5 more than double the width. The perimeter of a rectangle is 28 centimeters. What's the measure of each side? So, there's my rectangle. The length of the rectangle is 5 more than double the width. So we can call those length and width. And what we need to do is look at the problem, and we're going to assign one of them to be the variable, one of them to be a value of x. We'll say I'll use x for my letter every time. So the length of a rectangle is 5 more than the width, than double the width. And how I determine which one of those two things, so I'm asked to find two things, the length and the width, how I determine which of those should be the x, I think to myself, which would I rather know? Would I rather, if I could know one number, would I rather know the length of this rectangle or the width? And the way the question's phrased, I would rather know the width because the length is described in terms of the width. If I know the width, then I can use this sentence, 5 more than double the width, and I'll get the length. So I'm going to call the width x, and then the length is 5 more than double the width. So double the width would be 2x. 5 more than that would be plus 5. So there, we've kind of represented each of our things with a variable. The perimeter of the rectangle is 28. That's the next piece of information we need to use. And that's the piece of information we're going to use to turn this into an equation. So if I take the 4 sides of this rectangle and add them up, I'll get 28 as my answer. So that sort of gives me the basis for my equation here. And then 2 of the sides are x, so x plus x, these two sides, and 2 of the sides are 2x plus 5, 2x plus 5. All right, now I've got an equation I can solve for x. I'm going to look at this. There's a lot of terms on the left side. I'm going to combine the like terms. So 1x plus 1x plus 2x plus 2x is a total of 6x. 1 plus 1 plus 2 plus 2. And then plus 5 and plus 5 is the same as plus 10. So I've simplified that equation down. I've now got an easy peasy equation that we've done 10,000 times in the last 2 days. Not really, but we'll call it that. So there we go. 6x divided by 6 and 18 divided by 6. So we get x equals 3. So what that means is that the width is 3 because the width is what we decided x would be. And to figure out the length, I could use this little expression. 2 times x is 6, plus 5 is 11. Twice the width is 6, and then add 5 to that is 11. And I can double check. 3 plus 3 plus 11 plus 11. Well, 11 and 11 makes 22. 3 and 3 makes 6. So those two together make 28. So it did, in fact, work out. Now, I am absolutely 100% sure that you could have sat here and played around with numbers and eventually come up with 11 and 3 just by kind of messing around and drawing a few different rectangles. Thing is, I don't really care if you can do that or not. That's not the skill that I want you to learn here. What I want you to practice is being able to take these word problems and turn them into an equation so that we can use our mathematical tools to get there. That's sort of the skill that we're learning, and we're learning that because once you learn that skill, it'll work on any problem, even if it's more difficult than trying to figure out these side lengths of 11 and 3 where they work out really nicely and it wouldn't have taken you too long. That's not a transferable skill, whereas this skill learning here will let you solve more and more difficult problems as you move through your schooling. So that's what I want you to focus on. I don't care if you can come up with 11 and 3 without putting an x on a page. I want you to make the equation first. That's the skill that we're trying to learn here. All right. Tom, Richard, and Harry are 37 years old combined. Tom is 7 years younger than twice Richard's age. Harry is 4 years older than Richard. How old is each brother? Okay. So I think this is the second time I've used these set of names in my lesson. There's a joke buried in there you can ask your parents about, I'm sure. Tom, Richard, and Harry are 37 years old combined. Tom is 7 years older than twice Richard's age. So when I see something like this, again, we're trying to figure out three things. I'm going to write their names off to the side. I'm going to decide which of them should be X. So see if you can read through that problem and decide which one should be X. And again, the question you're asking yourself is, which brother's age would you like to know the most? If you could know just one of them, which one would you pick? And I would pick Richard. And that's because the other two brothers are both compared to Richard. Tom is blah, 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 blah than Richard's age. Harry is blah, 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 blah than Richard. Richard's kind of the pin in here that the other two things rely on. So that's what we're looking for here. Okay. So now I'm going to go back and make expressions for the other two. Tom is 7 years younger than twice Richard's age. There's twice Richard's age. 7 years younger than that would be 2x minus 7. Now, be careful. That's very different than this, right? So the order here matters. It doesn't matter that the 7 was written first. 7 years younger means you have to subtract 7. You're not subtracting the 2x. You got to subtract the 7. So that's how you have to do that one, 2x minus 7. Harry's the easier one, just 4 years older than Richard, so I would do x plus 4. So I've got them all set up, and then there should be one other piece of information we haven't used, and it's the total. If I add up all three names, all three ages, I get a total of 37. So there we go. So 2x minus 7 is the first brother, x is the second brother, x plus 4 is the last brother. Combine my like terms. I've got 2x plus x again. That's a total of 4x. I've got negative 7, positive 4, so that makes negative 3 equals 37. Add 3, add 3. 4x equals 40. Divide by 4, divide by 4, and we get x equals 10. And what does that mean? That means Richard is the person that's 10 years old. And then if Richard is 10, Harry is 14, 4 years older. Tom is 7 years younger than twice his age, so twice his age is 20. 2 times x is 20. Take away 7 is 13. You can check our math here. 13, 10, and 14, in fact, do add up to 37, so we're good to go there. Three more? What am I thinking? Okay. All right, last year Jacob's average was 85. So this is a pretend time where we used to have semesters and you'd have 4 classes at the same time instead of 2. And maybe we'll get that again next semester in February. Who knows what the future holds? Okay, but if he calculates his average, he gets an answer of 85. How you calculate an average is you add up the grades and you divide by how many there are. So we're going to add up his grades. He got 78 in one course, 94 all. Oh, I was going to make my French joke there. 78 all français, ha 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 ha. 94 in science, there we go. 93 in geography. That seems like the kind of grades I would have got comparing my French to my science. There we go. And he can't remember his history grade, so I'm going to put that as a variable. Maybe I'll use the letter H there. He's got 4 classes, so he divides by 4. So that's how I might set up an equation to that one. I'm going to multiply. So this is like all of this stuff added up and then divided by 4. So I'm going to multiply both sides by 4 to get rid of the divide by 4. 78 plus 94 plus 93. I guess I could have added those 3 things up first. Equals 85 times 4, which is 340, I believe. And then you can add up these grades here to combine those like terms. So 78, 94, and 93. I'm going to break down and pull out my calculator. Mr. Clement, isn't there software that you could use to edit out these dead spots where you're punching things into a calculator? No, there is not. Okay, 265 plus h equals 340, and then subtract off the 265. and I get a history grade of 75%. There we have it. Okay, so one more question, just like the Tom, Richard, Harry one there. So again, see if you can set this one up on your own, just like I set up Tom, Richard, and Harry just a second ago. So we've got Wolverine, Professor X, and Cyclops. You read through this question. Wolverine is 20 years older than Professor X. Cyclops is 17 younger than Professor X. Their total age is 180. How old is each hero? Well, you got to decide which of them is going to be X. Clearly, you're going to make Professor X X because his name has an X in it. Also, and more importantly, the other two are compared to him. Wolverine is 20 years older than him, so you're going to do X plus 20 for Wolverine. Cyclops is 17 years younger. Okay, this is an easier one. X minus 17. Put all those pieces of the pie together and you get 180. So X plus 20, X, and X minus 17 added up have to make 180. The X, and the X combine up to make 3X. 20 take away 17 is 3. So 3X plus 3 is 180. Subtract off the 3's. 177. Divide by 3. And we get 59? Does that sound right? I did pull out my calculator just a moment ago. Yeah, because 3 times 60 would be 180, so yeah, that'll be 59. I'm going to go with 59, which is far too young for Professor X, but we'll go with that. Wolverine would then be 20 years older, 79, and then Cyclops is 17 years younger, so that would be 42. And if you add up those three, absolutely you get 180. I'm not even going to check because that would reveal that my 59 is not correct, and I don't want to do that, but that's what should happen, so make sure. And if it doesn't happen, it means I divided that wrong, but I'm pretty sure I did it right. I'm in a silly mood tonight. Does it show? Okay, last one, I promise. Well, last one for me. You still have practice to do. Yeah. Okay. Get a simplified expression for the area of the following rectangle. So here, it's just getting a simplified expression for the area. It doesn't give us an area, so we're not actually able to solve for x. I'll show you why I didn't give you an area in a second. But in order to do that, we have to do length times width. Area is 2x times x plus 3. There we go. So remember, when you're multiplying something with two terms, you need to put those terms in brackets. So I might write that like that. And then to multiply that out, you'd multiply 2x by both terms. So remember, 2x times 1x, you get 2 times 1 is 2. X times x is x to the power of 2. That's one of our exponent rules that we're going to start revising tomorrow. But x times x, you add the exponents. X to the 1, times x to the 1, you add the exponents, and you get x to the 2. And then 2x times 3, well, 2 times 3 is 6, and then there's an x in that, so that would be my simplified expression. And the reason why I didn't give you an area to let you solve for x here is because in this case you get an x to the power of 2 and an x by itself, and you don't know how to solve an equation with an x to a power of 2 and an x term by itself, and you won't learn that until you're in the 10th grade in the future. So this, we can just get an expression, we can't actually solve for it. Okay, so you got some practice to work on, and if you could just send me your setup and answer for number 1, and then you can try the other ones. Number 4 is a good one. Yeah, those look good. Yep. All right, I don't know why I'm still recording. I don't know why you're still watching. Go do your work.